Hello everybody, we're getting ready to do 2.8 for Algebra 2. Here's 2.8, analyze graphs of polynomial functions. Here would be our standard for this lesson. We got a 26-point skill sheet that you can acquire at the end of part 1 here. And there's 12 points. You get a note-taking guide as well if you contact me. Here's your bell work, teachers. Give your students 5-6 minutes to do this bell work. Okay, welcome back. And after your students have finished your bell work, let's go over the solutions here. For number 1, here is our number 1 solution for number 1. The coefficients have 3 sign changes, so H has 3 or 1 positive real zeros here. Sign change, sign change, sign change. So it would have 3 or 1 positive real zeros. So we have a negative x of 5, 1, 2. The coefficients of h of negative x has 2 sign changes. So the coefficients have 2 sign changes. So h has 2 or 0 negative real zeros. It has 3 or 1 positive real zeros. And then it has 2 or no negative real zeros because it has 2 sign changes. Here is a change, and then here is a change. 3 positive real zeros, 2 negative real zeros, 0 imaginaries. So here are your possibilities now. The possible real zeros, the possible zeros, possible number of zeros of this, and here is your list here. 3 positive real zeros, 0 negative real zeros, 2 imaginary zeros. These lessons here are being taught in part 2 and part 3 of your lessons. This is why this is showing up here. To have the background to do these kinds of problems, you would have had to have parts 2 and 3 of the previous lessons. So this is basically what you've missed by not seeing part 2 and part 3 of the prior lessons. Then for the second one, you go over that in class. Okay, so you've graphed polynomial functions by making tables. You use intercepts to graph polynomial functions so you can maximize the volume of concept summary, 0 factors, solutions, and intercepts. And then here is our standard form of a polynomial. The following statements are equivalent here. 0, k is a 0 of the polynomial function f. Factor x minus k is a factor of the polynomial f of x. Solution k is a solution of the polynomial equation f of x equals 0. X-intercept, if k is a real number, k is an x-intercept of the graph of the polynomial function. The graph of f passes through k0. So these are part of the zero factor theorem of polynomials. Use x-intercepts to graph polynomial function. Here's our polynomial function here. Plot the intercepts because negative 3 and 2, we have negative 3 and a 2 are zeros of f. Plot those. And then plot points between and beyond the x-intercepts. So here is a grid here that can be used for your plot. And then we come up with a table here for input. You can either get it from a calculator or you can do it manually here. When x equals negative 2, y equals 8 over 3, which would be right about here, etc. So you get your plot there. Determine end behavior because f has 3 factors of form x minus k. And a constant factor of 1 over 6 is a cubic with a positive leading coefficient. So f of x as it goes from negative infinity as x goes to positive infinity. And f of x from positive infinity as x goes to positive infinity. Draw the graph so it passes through the plotted points. Here would be a plot here of that previous function. Students, you can do this on your grid that's provided for you here. Be careful to plot this like this, somewhat like that. Then we get into a guide practice here. We have 0.25 times this triad here of binomials. Students, this is U on U. Here is a table developed from this function here. Here is the table as it's yielded in a graphing calculator, which will be fine. You could enter this into a graphing calculator. And then here would be the plot here that you would get from that function. The x-intercepts are thus here and here. And the local max is at negative 0.79. So negative 0.79, which I guess would be right about here, and 2.05. So this is not quite, it'd be right here, about, approximately, it'll be there. Okay, there's that same function again. Then we have a local min here precisely at that. You can find these through using commands with your graphing calculator. You can find that. Turning points. Another important characteristic of graphs, polynomial functions, is that they have turning points corresponding to local max and min figures. So this would be a local max and local min. That's exactly what they are. They are turning points on these higher degree polynomial functions. The y-coordinate of a turning point is a local max higher than all nearby points, and then the y-coordinate of a turning point is a local min if it is lower than all nearby points. Okay, students, put this into your own words here: local max, local min. And that was part 1 of lesson 2.8. If you want part 2 and part 3, these are 3-part lessons. Email me here and I can provide those for you. Thank you.